Hi all, this is Honey. Welcome back to our channel Code with Honey. Today we are going to solve August day 25th LeetCode challenge, which is diagonal traverse. So we will be giving an M cross N matrix. We have to return all the elements of an array in a diagonal order. So yeah, if you see this example itself, you will understand, right? So it is going like this. Then we have to traverse to 4. From next we have to go from down 7, 5, 6, then 6, 8 and 9. Got it? So like this we have to traverse. So yeah, basically this is the question and we have to print it in that order in the resultant array. Okay, I hope this makes clear. And how we are going to approach this question, what will be our condition for going like this, how will be going to print this. Let's take a look. So here this is the example that I have taken. So to more precise, what we I'm going to draw a line, what all the, so these are the diagonal elements that we have to print it in that order. 1. Okay, first we have to go like this: 1, 2, 5, then we have to go 9, 6, 3, then 4, 7, 10, 11, 11, 14, 17, 14, 11, 8, like this. Hopefully it's like kind of spiral only, but we have to print in a diagonal. So if you see, as after seeing this question, what comes into our mind? So we have to, for sure we have to traverse back, up down we have to do. But what is the head of this? All this and all this, right? So let's forget about traversing up and down. Okay, now what if everything we have to print it in like this diagonal element from the start? So if it's that's the case, what will be our, so okay, we'll be starting with, this is the head and you will be traversing like this. So this is the head, you will be traversing, this is starting row -1 column -1 will be giving us this. Now if you start row -1 column -1 will give you this, again row -1 column -1 will give you this. If you start at here, then row -1 column -1 will give you all this. Okay, until you reach the row and the, either if you reach the end of the 0 for ith index, or if you reach the end you should terminate the loop. That's what we are going to do, right? So then once you have traversed all this, what if you start from the column? Same, row -1 column -1 row -1 column -1 row -1 column -1. Yeah, this is our basic approach that we are going to do to solve this question. So basically our head, where we will be starting, will be traversing only these. Okay, after that we'll be doing row -1 column -1 to achieve all the elements. So we'll be checking, we'll be having these as a so total how many traversal will be, this we will be calling n. Okay, n is the length of the matrix, this is the length of the row, right? So length of row, length of column, if you traverse, so this will come in column and row both. So so this will give you the total number of traversal, correct? Okay, once you traverse that, what we will be doing, we'll be just doing r -1 c -1. Got it? So that is what we are going to do. So basically our total traversal will be, so 10 plus m -1. Got it? So we have to figure it out every time head index. Okay, this is the head, this is the head, this is the head. Okay, so what we will be doing for that head index, so what we'll be doing will be like head index. How we'll be figuring out that head index? Head index in range n plus m -1 or total traversal. Okay, so now head will be 0. Okay, this will be from this 0. How will you know which row column you want? So that you can do row minus 1, column minus 1. So how we will be figuring out the row? First will be take the row and column. So now our head index will be 0, 1, 2, 3, whatever it is. So whatever it 0, 1, 2, 3, the row will be 0 only, right? So until it was 0, 1, 2, 3, our row will be 0. Okay, row will be 0 if head index is less than m. Okay, when your head index is nothing but will be total. In this case, our head index will range from 0 to total, it is 8. Okay, so how we will be dividing that? So 0 to 8, 7, it will range, correct? So 0, 1, 2, 3, 4, 5, 6, 7. Got it? So this is how. So when the head index goes 0, 1, 2, 3, it will be fine. Here our m will be 4 and n will be 5. Right? This is our n, this is our m. Okay, n is 5, m is 4. So until m less than m, 0, 1, 2, 3, your row will be the same. Row is 0. When row will keep increasing, if else, what will be doing? Index is greater. Okay, when it comes here, we need to get the row position. So when head index goes from 3, 4, okay, you have to subtract this many rows. So I will be giving head index. So head index minus m plus 1. So head index, if it is 5, which means this is the head, it will assume. But we wanted the row. How will you write? Sorry, 0, 1, 2, 3, 4 here. So here when you have to traverse, our head index will be 4 at this point for this diagonal elements traverser. So when it is 4, you will have to subtract this. 4 minus 4 plus 1 will give you 1. That is the row. Got it? This row element is the starting and column will be m for that case. So else what we will be doing? Head index minus m plus 1. So when here it comes, it will be 5 minus 4 plus 1. Our head index will be, row will be 2. When it comes here, 6 minus 4 plus 1, 7 minus 4 plus 1. So always this will give you the corresponding row based on the head index, right? So the same for column. So column will be keep on increasing when if the head index is less than m, right? See, when the row equals to 0, okay, our head index will be the same and the column also will be the same. So you can give the same head index. Instead of doing col plus 1, you can give, okay, head index itself. If head index is less than m, when it goes came m, it will be always m minus 1, right? So for this traversal of rows, our head index will be always m minus 1, like how we are always 0. Now the column will be same. Got it? Else m minus 1. So this will be the column and row. So when the head index is 0, so now the head index will traverse from 0 to 7, or when our head index is 0, our row will be 0 and our column will be 0. When head index is, so we will be traversing like this. So when the head index is 1, okay, our row will be 0, column will be 1. Got it? So once you got 1, now you have to traverse to 5, right? How, as we mentioned, we'll be going with doing this is the row column you figured out. So what will be this? Row minus 1, col minus 1. So while row should be less than n and call should be greater than or equal to 0, we will always have a temporary array for every head index. So now what we'll be doing, so we'll be getting the matrix element and we'll be appending to the temp. So matrix of row and call. So now we'll be appending 2 5 initially for head index 0, row will be 0, column will be 0. So now what we will be doing, we'll be doing row plus 1 plus or equals to 1, column minus or equals to 1. So now when the head index is 0, a row would have 0, column would have 0. So row would have got incremented to 1, call already 0 minus 1, so it would have terminated. Now the temp will have only 1 as a answer for the head index equals to 0. Got it? So now will be having a top result which will have all the answer. So now for the head index 0, our answer was 1, that we will be getting appended to the result after this. So if head index mod 2 equal to 0, so you have to reverse the array and append. So as we they have mentioned, we have to go like this, then this, then this, then this. So this is 0, this is 1, this is 2. So when it is mod 2 equal to 0, we have to reverse, right? So this is 0 1 2 3. So odd index we can just append. Now we are just traversing every time like this and we are just reversing if it is odd. Okay, that is what we are doing. Head index mod 2 if it is, then what we will be doing will be append result dot extend temp. This is reverse, else you just append straight away. Got it? This is the way, this is how we are going to do. So now for the temp equals to 1, we have appended to the result state. Even if you reverse, since it's only one element, so it will get updated to 1 now. Now when the head index is 2, okay, what we will be doing, will be updating 2 comma 5. So our row will be less than m, row will be 0, our column will be 1. Okay, row is 0 and our column is 1. Now think, if row is 0 and column is 1, first we will be updating row 0 and column 1, which is 2. Row minus 1, column minus 1 will come here, right? Basically row minus 1 and column minus 1, row plus 1. So we'll give you this 5. Okay, then we'll be updating that 5. Again, if you are doing row plus 1, column minus 1 is exceeding the index range. So now we are terminating the loop. Now if you see, this is 1, head index is 1. So 1 mod 2 is not 0, so we'll not be reversing, we'll be just appending the same. Okay, 1 2 5. So next our head index will be 2, row will be the same because that is less than m, which is 4. So column will be 2, so 0 and 2, which means 3 6 9 will be getting, right? Row 0 and column 2, row minus 1, column minus 1, row plus 1, column minus 1, row plus 1 will give you 3 6 9. So 3 6 9, if you see, this is second index, right? So which is head index mod 2 equal to 0. Our temp will be 3 6 9. Now 2 mod 2 equal to 0, so we have to reverse, which means 9 6 3 will be updating in our result. Okay, next head index will be getting now updated to 3, row equal to 0, column equals to 3. This is 4, this is 3, this is 0. Okay, which is less than 4. So we'll be updating the 4, 7, 10, 3. By with this we'll be updating 4, 7, 10, 13, right? So 3 mod 2 is not 0, so we'll be straight away updating that. 4, 7, 10, 13. Okay, when row head index gets updated to 4, row will be head index 4 is not less than 4. So what we'll be doing, 4 minus 4 plus 1. Now row will get incremented to 1. Now row is this, and our column now will be m minus 1, because we have traversed all m's. Now we'll be traversing all n. So now what we'll be doing, we'll be getting row plus 1, row is 1, our column will be always same after this, which is 3, row will be 1. So 1 of 3 is 8. So once you got this head index, we'll be doing row plus 1, col minus 1, row plus 1, col minus 1, row plus 1, col minus 1. So will be 4, 8, 11. All this will be getting, but our head index will be mod 2 equal to 0. Now we have to reverse. So temp array will be like having 8, 11, 14, 17. Now we have to reverse the temp array and update to extend the result. So 17, 14, 11, 8 will be getting updated. Got it? Next we'll be getting row 5 minus 4 plus 1 will give us row equals to 2. The same third. Now we'll be getting 12, 15, 18, and 5 mod 2 is not 0, so we'll be updating the same. So now head index will get updated to 6. So 6 minus 4 plus 1 will give you 3. 3 of 3 is 16. So now from 16, row minus 1, col minus 1 will 0 plus 1, col minus 1 will give you this. Col minus 1 will go, but row plus 1 exceeds your array limit, so which will have only 16, 19, but 6 mod 2 is 0, right? So we'll be reversing the array and we'll be updating. So 19, 16, then finally head index will go 7. 7 minus 4 plus 1 will give you 4. 4 of 3 is 20. So we'll be just updating the temp, and row plus 1, col minus 1 will exit the. So this is our final result array. I hope this makes sense, right? Why we are doing. So basically we are not just doing anything, we are just using the same row plus 1, col minus 1 for everything. We are figuring out the head index from where it has to start. Okay, but if it is mod 2, we have to go up and down, right, at each alternate iterations. So what we are doing, instead of writing different condition, we are doing the same, and when the test mod 2 equal to 0, we are just reversing the output that we got. Okay, I hope this makes sense. So this is the exact solution that we have used to solve this particular problem. So if you see, if this is a base condition, if either matrix was not defined or matrix 0 was not returning, so we'll be taking n cross m, which is the length of the matrices. So and we'll be passing the head index, as we know this is the -1 will give you the number of rows and columns. So every time we are clearing that temp, so that we'll be having only that traversal element. So we'll be finding row and column. I have explained how this condition works. So the same row plus 1, column -1 will give you the diagonal elements. So then if the head mod 2 is equal to 0, then we'll be reversing the array. That's it. So the time complexity for this will be order of m cross n elements, because even though we are traversing n, head index is going n plus m, in between we are traversing all the elements, right? So in total it will go order of m cross n. So this is the resultant array that we need to return. So that's not additional space complexity. So space complexity is something that we are just using the temp. So temp is nothing but it will store the maximum of for this element m. So at any point it will have the maximum of n or m, whatever the minimum we have, that will be the so n to the max, what it will store 4 elements, right? So minimum of 4 comma 5 is 4. Here the diagonal elements to the max will be having minimum of n comma n, that will be our space complexity at any point. Okay, yeah, I hope this makes sense to you guys, why we are how the simulation works. If you have any questions or concerns, please do leave a feedback, or if you want me to explain better at any point, also do leave a feedback so I can improve myself better and provide more quality videos. I'll be providing solution in all languages in the GitHub. I'll be providing the GitHub link in the description. Please do check it out. Yeah, I hope you would have understand and you will also solve and have stick together. If you like my video, please do like, subscribe and share it with your friends for more daily LeetCode solutions. Hit the bell icon so whenever I am posting the video, you will be getting notified. So yeah, let's code together. Thanks for watching.